let's go over some of the basics of our linear equations. So the basic form is y equals mx plus b. So that's our slope-intercept form. There are other forms out there, but this one tends to be the best for graphing and analyzing and everything like that. It's a good setup. So, slope-intercept form. Our slope is represented by the letter m in that equation. So we have our variable y, we have our variable x, and then we'll have these two numbers that we'll fill in the blank for. So m will be our slope, which will represent our rate of change between 2 points. And then b will be the y-intercept, which we'll talk about below there. So let's focus on slope first and the different ways we can think about it. So one way to find slope is to have two coordinates and just see how is the change occurring between those two coordinates. What we do is we create a fraction where we look at the difference in outputs over the difference in inputs. So in the numerator, we're going to look at the change in y over the change in x. So let's see the different ways we can find our slope. So if we're given two coordinates, then what we would use is that formula up above there. So what can help is noting what's your x1, y1, and what's your x2, y2. It doesn't really matter which point is 1 and which point's 2, you just have to be consistent. So let's say this is x1, y1, x2, y2. So for slope, I would take y2, which is -8, minus y1, which is +2, and then divide that by x2, -7, minus x1, which is a -2. So when you're plugging in negatives for that second spot, be sure you have subtraction of the negatives, so using parentheses can help there. So in the numerator, -8 minus 2, so -10, over -7 plus 2, so -5. So that's going to be a +2 slope, and that all simplifies down. So something I do if I'm unsure if I plugged it in correctly, you can look vertically, and that should be one of the coordinates. So in the numerator, you'll have y values and the denominator x values. So that -7, -8 showing up there, and then that -2, 2 is showing up there. So they should line up. Alright, finding the slope given the equation of a line. Well, if it's in slope-intercept form, this is nice and easy because that's our slope. We just have to find it. It's always the piece multiplying with x, because sometimes they might give you the equation of the line is like -8 plus 5/2 x. And that would be the same exact equation, but looking for slope, you're always looking for the value that's multiplying with x. So for this case, our slope is +5/2. Alright, given a graph, what we want to do is think about it in terms of this change in y over change in x. So calculating slope, I want to think about a fraction. Now to do this with a graph, I want to look for two clear points that I can map between. So I'm going to look for, here's a clear point right here at -420. And then I want to find another point that's pretty clear on the grid. And I'm looking, and all the way down here. Awesome. Alright, so I want to see how can I get from one point to another with only looking at this kind of idea of up, down, left, right. So change in y changes by going up or down. Moving up is considered positive, moving down is considered negative. For x, we're looking at moving right or left. So horizontally, moving to the right is considered positive, moving to the left is considered negative. So what I want to do is, sometimes I think about it being like a little bug is traveling on this paper, and it can only follow the grid. And what they want to do is get from this spot to this spot. So what we could imagine is that they're going to go downward. So they're going to go down, but then they'll stop here because then they can turn and move to the right. So with that, I have this map. So in blue here, I'm moving downward, so that's a negative direction. And then for our units, we're going 10, 20, 30, 40, 50. So we moved down 50 units. And then horizontally, we moved to the right, so that's considered positive, and we went 1, 2, 3, 4, 5, 6, 7 spots. So for slope, what I'm going to do is take that change in y, which is the negative 50, over the change in x, which was that positive 7. So we have negative 50/7 for our slope. So it's the different ways to visualize slope, with coordinates, or the equation of a line, or with a graph. Alright, intercepts. So the y-intercept shows up in our equation of the line, if we're in slope-intercept form, and it's the value where we're crossing the y-axis. So it's a coordinate, we're getting out this coordinate that's 0, and then this value for b. So if we had, I'm going to squeeze this in here, but if we had a graph and say we have our axes and I graph something linear, our y-intercept would be this point right here. That would be our 0b, crossing that y-axis, because x would be 0, but then we'd have some output for y. The x-intercept is the same idea, but along the x-axis. So this would be a coordinate where y is equal to 0, so we'd have some x-coordinate, but then y would be 0. So on my little graph that I just drew there, it'd be the spot where we cross that x-axis. So I'd have some x value, and then 0 for y. So let's look at the different ways that we can find these x and y intercepts. So with a line that passes through 2 points, what we need for our intercepts is the actual equation of the line. So we could plug zeros in and see our y-intercept. So we already did some work with this because we found up above that our slope is 2. So what I can do is start the equation of my line. I know y equals 2 times x, but I don't know what the y-intercept is, so I'm just going to say plus b. But what I can do is solve for b, and I can do this by plugging in one of the coordinates. So I'm going to go ahead and plug in -2, +2. So the y-coordinate is +2 equals 2 times x, which from our coordinate is -2, close those parentheses, and then plus b. And now we can solve for b. So 2 equals -4 plus b. Add 4 to both sides of the equation, and we should be getting a b equals 6. I apologize, I work on my 6s, but they love to look like b's, so I'm going to try really hard. So we have this equation of a line that is y equals 2x plus 6. Yeah, that's good. So from that, we can see our x-intercept. Our x-intercept is the point, or sorry, y-intercept. Don't know why I keep mixing those up. Y-intercept is that value for b of 6. So we have a y-intercept of 0, 6. So we can see that. What we still need is the x-intercept. And with that, what we can do is plug in y equals 0. So what I'm going to do is plug in 0 equals 2x plus 6 and solve. So that would be -6 equals 2x. Divide by 2, and we have a -3 equals x. So that would give me an x-intercept of -3, 0. So with that example, we had to find the full equation of the line in slope-intercept form. And that came from already knowing the slope as we calculated it up above, plugging in a coordinate. And when you plug in the coordinate, then you can solve for b. And then that would give you your y-intercept once we have that value for b. And then to solve for the x-intercept, we would just plug in y equals 0 and solve. All right, for this next one, we can find our y-intercept pretty quickly because it's shown in the form there. So it's at -8. So we have a y-intercept of 0, -8. For the x-intercept, we're going to do the same thing that we did in that previous example, where we're going to plug in y equals 0. So we're going to have 0 equals 5/2 x minus 8. And we're going to solve. So I'm going to add 8 to both sides of the equation. And then there's a few different ways to go about this. We could just multiply by 2 to clear out the denominator there. Another thing we can do to make that coefficient of 1 is that we can multiply by the reciprocal of the fraction, which means take the fraction that you see there and flip it. So if I multiply by 2/5, then I get all these cancellations so that then I'm just left with 1. So we're going to multiply by the reciprocal. So nothing really cancels out on this left-hand side, so we're just going to have 16/5 from the multiplication 2 times 8 in the numerator, and then technically a 5 times 1 in the denominator, and equals, and over here, like I was saying, those 2's would cancel out, those 5's would cancel, or you could think of it as if you multiplied, you'd have 10/10, which is just 1, but that would leave us with x. So we get this kind of messy x-intercept, but it would be the coordinate 16/5, 0. So if we have the equation of the line, then we can just find the y-intercept, but we need to calculate the x-intercept by plugging in 0 for y. All right, from a graph, you should just be able to find the points. So the y-intercept is about right there. We're going to have to estimate a little bit. And then the x-intercept is about right there. So let's say, I'm going to go ahead and make a note that we're estimating here. These are estimates. So for the y-intercept, 0, looks like it's pretty close to -10. Let's go ahead with -9. I could see -8 as a possibility. X-intercept, we have our x-coordinate is, let's see, -1, and then maybe it's kind of close to like a quarter of the way, so how about negative like 1.25? I mean, it should probably just be, it should be more than -1, definitely less than -1.5, so somewhere in that range, and then y-coordinate of 0. And this actually shows exactly why. So graphs are nice visually, but when you want exact values, they're really hard to work with. In the end, it's really nice to have the actual equation so you can solve and get those exact values out, where with graphs, we can see trends, we can see so much with them, but in terms of getting exact values out, sometimes it's not that great. All right, so there's some basics of our linear equation.